Okay, so for our topic today, we are going to talk about a sequence, all right? So in this class, I will be teaching you how to identify whether the sequence are linear or non-linear. So basically, a sequence is just an arrangement of numbers with a certain pattern, so we call them a sequence, okay? So let's go back to this topic over here. So how do we identify a linear or non-linear sequence? Now, very simple, to identify whether they are linear or non-linear, all you need to do is to find their term-to-term rule. So what is that? Okay? So very simple, if you want to talk about term-to-term rule, all you need to know is from the number to the next number, all right, from each number to the next number, what is the changes, okay? So in this 6 to 4, 4 to 2, 2 to 0, and so on, you can see that they are always subtracting 2, right? Okay, correct or not? So this thing over here, this group of numbers over here, we call them term to term rule. Okay, we call them the term to term rule. Okay, so over here, all right, if you notice in this sequence over here, they are subtracting, all right, they are subtracting, okay, the same numbers over here. So because of that, we can say that this sequence is actually a linear sequence, okay? So I can make a general summary over here. The sequence it's subtracting. I will highlight this and I will mention you in a while. It's subtracting. The same number and hence it is a linear sequence. Okay, so when you see an example that looks like this, they are subtracting the same number, so it is a linear sequence. Now it's not only for subtracting, okay, it is also for adding. If they are adding the same number, it is also a linear sequence. Okay. Now, if I would like to give a general formula, how do I get this -2? Now, this is fairly easy to see. 6 to 4, that's going to be -2, right? But in mathematically, how do I show this? So there's a simple formula over here. We will choose the term, all right, that you're interested in. It can be any number, so I will just put an unknown, which is n over here, okay? All you need to do is to take it and subtract the term before it. So I will put n minus 1 over here, okay? That will give you the term to term rule over here, okay? So for example, over here, how do I know everything is -2? Let us say I just chose this term over here, all right? So this is the term that I'm interested in. So this is what I call term 1, term 2, term 3, term 4, and term 5, okay? So I'm interested in this term, which is 4, and I have to subtract the term before it. So since I choose term 2, all right, this is 2, so I have to subtract the term before it, which is term 1. So 4 minus 6, and true enough, that will give me 2. Okay, so that is what the formula means. So same thing over here. So let us say if I'm interested to, check from here, term 4, T4, all right, which is the number is 0, all right. I have to subtract the number before this. So that's going to be term 3, 4 minus 1, that's 3. So 0 minus 2, that's going to give me -2. So that will be the general formula to find term to term rule, okay? Now what about the next example over here, all right? The next example over here. Now this next example over here, let's look at this again. All right, let's check from one number to another, what is the changes, okay? Now in this case, all right, some of you may be able to see directly, all right, but some of you maybe not. If you're not able to, do not worry. All you have to do is just to use the simple formula over here. So let's just say I'm interested to choose this number. Okay, so all I have to see is to take this number and subtract the number before it. So you can choose any number. You can choose this number and subtract the number before it. Okay, so let's try the first one. So the first one, that's going to give me -7. All right, to find term-to-term rule, I'm just going to write short form. Okay, so I'm going to have -7. I will be subtracting -3. So I will be subtracting -3 over here. Okay, so what do I get now? So I will get -7 plus 3. That will give me -4. Okay, so over here I know that this is actually -4, and I can check for this as well. All right, okay, I can check for this as well. So if I have -11, okay, the term-to-term rule, I have -11. I subtract with -7. Okay, so -11 plus 7, that will also give me -4. Okay, so I know this is -4 as well, and true enough, this is -4 as well. So since we can see this sequence over here, the term-to-term rule, all right, it is subtracting the same number, all right, throughout the sequence. So we can say that this sequence is a linear sequence as well. Okay, all right. So what about this guy over here? All right. So same thing. Let's try to find the term-to-term rule. Okay. So let's check what's going on. So we can do this very quickly. All right. 5 minus 8. That's gonna give me -3. And if you do this very quickly, you will get -4. This will be -5, and this will be -6. All right, so we can see right here that you can see that the numbers are subtracting different numbers throughout the sequence. So, okay, since they are subtracting different numbers throughout the sequence, we say that this is a non-linear sequence. All right. So linear sequence is only true when the number, all right, the term-to-term rule, is adding or subtracting the same numbers. Okay. So just to show you one positive example, I'm just gonna do this very quickly. So let's just say I have 2. Okay. Let's just say I have this type of number. So you can see the term-to-term rule here over here is always going to be +3, +3, and +3, right? They are adding the same number across. So since the term-to-term rule is adding the same number, so we can call this a linear sequence. Okay? Alright, so I hope you have a general understanding of what is a linear sequence now. So let's go to the next example over here. Now the first term of the sequence is 3, alright? The first term over here, I would like to address this as T1, that's my first term. It's 3, okay? I'm going to put 3 over here. And they said that my term-to-term rule, it's multiply 2. So it's always multiply 2. And I'm interested to find the first 3 terms of the sequence. So I have T2 and T3 over here, okay? So this one, it's also multiplied by 2. So let's do this very quickly. So this one, I should get 6 over here, and then I should get 12 over here, okay? All right, so that's the sequence, right? And we are done. But my question for you, if you take a look at this, is this a linear sequence? All right, is this a linear sequence? So you can take a time and think, all right? If you say this is a linear sequence, you are wrong, okay? This is not a linear sequence. This is actually a geometric sequence, but we are not going to go in depth on this sequence right now, all right? But I will just tell you why this is not a linear sequence, because let's come back to our definition for linear sequence here. Okay, linear sequence is a sequence when you are subtracting or adding the same number. But in this case, they are multiplying the same number. They are multiplying the same number. Okay, so this is not a linear sequence. Linear sequence only apply for when you are adding or subtracting. So I'm going to make a definition over here for linear sequence. I'm going to improve this. So linear sequence, let me write this down. Okay, so over here that is the general idea of what linear sequence is, okay? So it's when you are adding or subtracting, okay, the same number that's linear sequence. So this one looks like a linear sequence, but it's not because it's multiplying. All right, I can also check this very quickly with you. 3, 6, and 12, how do we find the term-to-term rule for linear sequence? The second term, all right, and subtract the term before. So this and this, that will give me plus 3, and here to here, that will give me plus 6. They are adding different number. So this is not a linear sequence, okay? It's another type of sequence which is called geometric sequence, but we are not going to go in depth for now, all right? So let's try this one. The first term is 0. So I have term 1, which is 0. And the term-to-term rule is add 3, then square, okay? So my term-to-term rule from here to here is going to be some number, which is 0 in this case, is I'm going to add 3, and then the whole thing, I will square it. That's my term-to-term rule, okay? So they ask you to write the first 3 terms, so which means I have term 1, term 2, and term 3. So what do I get? Okay, so in this case, it's going to be any number plus 3 that will give me square, okay? In this case, it will be another alphabet lah. Let us say over here, that's y, okay? So how do we find y right now? So whatever number you substitute here, which is 0, 0 plus 3, which you get 3, 3 square, and then you will get 9. Okay? And then over here, so you will do the same thing. 9 plus 3, alright? 9 plus 3, 10, 11, 12. You will get 12, 12 square, and then you will get 1, 4, 4 over here. Okay? So that's what it means lah. So again, my question for you, is this a linear sequence? The answer is, it is not a linear sequence for this case, okay? Because over here, you can see they are both adding different numbers. They are not adding the same term-to-term rule, alright? Not adding the same number, so this is not a linear sequence, okay? So I hope that this example shows you I hope that you understand what is a linear sequence now. Now let's look through the last example over here. So I asked you to find the missing term for the linear sequence below. Now I have highlighted linear sequence over here, and that is actually the keyword. So what do I know? It's every numbers over here, they are actually either adding or subtracting the same number. So how do I solve this? So the first thing, I will find the term-to-term rule first. Term-to-term rule, okay? So it's going to be the number that you choose, and you subtract the number before it. So in this case, that's going to be 12.4 minus 18.6, okay? And you should get my negative 6.2 over here, okay? So that is my term-to-term rule. So I know that from here to here is actually minus 6.2. And since it is a linear sequence, I know everything is actually subtract negative 6.2. Okay? So right now, this is all my unknowns. So let me call this A, B, C, and D. So they want to find the missing term. So this is going to be very easy now. I'm going to do C and D first because that will be the easiest to do. Okay? So to find C, alright, to find C, all I have to do is to take 12.4 because it's a linear sequence. I know it is going to be subtracting 6.2. Alright, which that will give me 6.2. So over here I actually know it's 6.2. Okay, so for D, it's gonna be 6.2 minus with 6.2, and that will give me 0. Okay, so I know this is 0, and true enough, 0 minus 6.2, and that should give me 6.2. Now what about A and B? Okay, so what should I do? So for me, I would like to find B first because there's a reverse step. So how do I find for B over here? So always I will craft out my equation. So if I will say, I want to find B, I will say B, I have to minus 6.2, and that should give me 18.6. Alright, and that should give me 18.6. So we can solve this by having B, okay, move it over, so I will have 18.6 plus 6.2, and that should give me 24.8. Alright, that should give me 24.8. Alright, so since I know what is the number now, I can find A. So same thing, A over here, it is minus 6.2, and that should give me 18.6. So I can just rearrange my equation very quickly. So that's going to be A, and that's going to equals to 18.6. Sorry, not 18.6, my bad. That is supposed to be 24.8. 24.8 plus 6.2, okay? And A should give me 31. Okay, it should give me 31. Alright, so that is how we deal with linear sequence, alright? And that is how we deal with the various problem over here. Okay, I hope everyone understands this. Thank you.